Welcome to this third in the 2024-2025 season of the Silicon Web Customers Guild Presents webinar series. Today's webinar is Laser Cutters for Customers, presented by Taylor Pope. Silicon Web Customers Guild Presents webinar series offers talks by speakers on a variety of topics about costumes and costuming. The webinars are free to Silicon Web members, and they may also be available to the greater costume community on a space available basis. If you have feedback or suggestions for future speakers or topics, please send them to webinars@siwcustomers.org. The chapter would like to acknowledge the International Customers Guild Marty Gear Costuming Arts and Sciences Fund for a grant award in support of developing this webinar series, and the International Customers Guild for making its Zoom platform available to chapters and special interest groups. A couple of notes on Zoom. Please set or leave your video and audio controls on mute. Feel free to chat or react during the presentation. There'll be a Q&A period after the presentation. To ask questions, just type it into the chat window. We may take questions during the webinar itself as well, so please type them in as you think of things to ask, and we'll answer them at the appropriate time. When the webinar is over, please complete a brief survey on your experience. We use this to help improve future webinars. A little bit about the talk. Lasers are a fixture of science fiction, and in this webinar, Taylor Pope will introduce you to the benefits of using real-life lasers in custom fabrication. Laser cutters are especially good for tasks that require precision and repeatability. Taylor will give an introduction to different types of laser cutters and present on how he has used them in costuming projects. He'll also discuss how to pick a laser cutter that is suited to the task and budget, and how to make designs for cutting at home, sending to a laser cutting service, or for use on a laser cutter at a makerspace. Taylor's costuming focuses on inflatables and digital fabrication techniques like laser cutters and 3D printing. He's the vice president of the Silicon Web Customers Guild and its ICG Board representative. Taylor and his wife, Megan Gardner, received a Silicon Web Customers Guild Dana Ray McDermott Memorial Award at CustomCon 39 in 2023 for their wacky, wavy-armed tube creatures, inflatable costumes featuring Elmo and Grover from Sesame Street. And you can see an image of those two in the lower right-hand side of the screen. They wrote the feature article entitled Inflatable Cosplay for the February 2024 issue of Silicon Web's The Virtual Costumer magazine about their work with inflatables and inflatable costumes. And here's a link that you'll be able to follow to that issue. Taylor and Megan were recently featured on Adam Savage's Tested YouTube channel when they attended the SF Bay Area Makers Fair with their inflatables. And here's a link where you can watch their performance on YouTube. So with that, I'm going to turn the presentation over to Taylor, and please take it away.
Hello, everyone. To get started, I'm going to begin with some general introductions to hobbyist laser cutters, talking about different types that are available and different ways to access them and go about using them. And then after I talk about more on the general side, I'll dive more deeply into how we specifically have used them and my experiences and some of the learning curves I've gone through on that front. Right out the gate, I want to hit on what I think every discussion of lasers definitely needs to include is safety. When you are working with laser cutters, you are dealing with very high intensity light that is deliberately tuned to be able to have enough energy that it can cut things. Part of that is that stray reflections can continue to carry enough energy that they would be very damaging to eyes. And so it's important to either have a laser that is fully enclosed, generally referred to as a class 1 laser, or to have eyewear that blocks the wavelength of the laser, so that if something does go wrong and a laser beam directs towards your face, your eyesight is not at risk. One key element when you are going to be working with lasers is understanding what the risk profile is and making sure that you have not only eyewear, but eyewear that is appropriate for the laser. Different lasers have different spectrums of light that they work with, which means that glasses meant for one laser won't necessarily be useful for working with another laser. But it does also mean that because it is a narrow bandwidth, you can usually get glasses that retain a large amount of visibility, so you can still see what is going on while blocking the important wavelengths. Aside from that, ventilation is the other major safety concern with lasers. Regardless of what you're cutting, when you're laser cutting, you are vaporizing a material that causes smoke to get in the air, which is not great for your lungs if you don't have good ventilation. Beyond that, there are many materials that when cut could be substantially negative, have more negative compounds being released into the air. This is especially true for compounds that contain PVC. The chlorine in chlorinated vinyls is especially bad for not only you, but also your equipment. It can cause damage to the equipment, damage to your lungs. And so it's important to avoid anything that contains PVC. As you get more into laser cutting, there are often discussions about which materials are and are not safe to cut. Obviously, that's a spectrum. If you have very bad ventilation, you can give yourself health problems with raw wood and paper. If you have good ventilation, you can get away with a lot more materials, especially on the plastic side, that are not necessarily highly toxic, but can smell very noxious and be unpleasant to work with without properly filtering or extracting the contaminated air. When you are working with lasers, there are a few major types that you're likely to come across in hobbyist lasers. I'm going to share my screen and show a couple of images of lasers that I have. The laser that I started off with is a CO2 laser. These lasers will have a laser tube in the back that generates the laser itself, and then have mirrors on the gantry and that move around and reflect the beam to the specific down along this axis, down this axis, and then a final laser that directs it at the workpiece in the laser head that's moving at the tip of the gantry. This allows you to have a fairly high-powered laser that moves rapidly without much weight on the gantry. The CO2 lasers are where I started off, but they're kind of the mid-tier of hobbyist lasers. The cheaper tier entry lasers are often diode lasers. Those are substantially smaller. They are more similar to the laser pointers you might have seen, but they're in a wavelength and a higher power that's more suitable to cutting. This laser cutter that I have is actually very large. This is a 1 meter by 1 meter gantry, but the laser itself is a small piece that the entire laser unit is moved around. That simplifies the machine substantially. It means you don't have to have it calibrated nearly as precisely. With a mirror-based setup, everything has to be aligned just right for the beam to get through the whole system to the end, especially as the gantry moves over the course of the available workspace. With this other setup, because the entire laser is contained at the tip, if the gantry itself is a little bit poorly calibrated, it could cause some inaccuracies in the specifics of what you're cutting, but the laser will continue to work as intended because it's just firing straight down. The final of the three main types of lasers you're likely to come across as a hobbyist laser are diode lasers. Diode lasers are something that I have no personal experience with, but they are a higher wavelength that is able to interact with metal, whereas these two have very limited ability to do anything to metal materials. Diode lasers are often used as marking lasers, especially because they can be very precise and can even be tuned to the point where if you use them with certain metals, they can oxidize at different powers to cause different color effects. This can result in being able to even do color markings with a marking laser, as well as being able to do depth-based engravings by engraving away some of the metal materials. When you are dealing with a laser, it is likely going to be based either on a gantry with a X and a Y axis and belts and wheels moving, as both of the lasers that I have, or on a galvanometer, galvo for short. Most fiber lasers are galvo based, which means that instead of having the XY axis that moves either the mirror setup or the laser itself, you'll have a fixed laser that fires at two different mirrors that use complex math to direct those two mirrors to point the laser in the workspace. Galvo-based lasers usually have a much longer focal length, but a much smaller working space, because instead of moving the laser where you have a fixed depth, it rotates slightly and the distance changes. And so over too large of a working space, parts of it would come in and out of focus. They also tend to be focused more on raster engraving than vector engraving. Sorry. When you are working with a laser, there are two main modes you'll be working in, as I just touched on, raster images and vector images. A raster image is an image that is made up of individual points. This works much like a laser printer or an inkjet or laser printer, where it will scan back and forth. And on each scan, it will either make a point or leave blank every point it goes across. This is how you would print out an image, by having a row of points, then next row of points, the next row of points squished together tightly enough that from a distance they blend together into a smoother image. With raster images are common. That's the majority of what we are familiar with interacting with. But vector images are where laser cutters are a little bit more unique. In addition to engraving point by point, a laser cutter can be used to engrave a specific shape. That method starts with, instead of having a back and forth motion, the laser follows a precise contour defined in the software ahead of time. This can be especially useful for cutting out pieces, but can also be used for surface level engravings when you are wanting an effect that's more like hand drawn than something that's made by a printer, as it will be made up of individual lines at the end instead of dots that blend together to form an effect. The 3D the laser cutter, the hobbyist laser cutter landscape is very interesting in that while the machines themselves are very similar to 3D printers, the cultural surrounding is very different. A large part of this is because of the history of how these different communities evolved. 3D printing initially was an industrial process that was not approachable by hobbyists or even small companies until the RepRap project created more or less from scratch the idea of a hobbyist laser printer. Because of that, and because that was an open source project, the 3D printing community that grew up around that was largely grown from scratch and with a lot of open source DNA. Things like Thingiverse came out of that, and several of its descendants are why 3D printing has so many online repositories of things that you can just download and create. In contrast to that, laser cutting was a more common small industry tool before it worked its way into hobbyist spaces. It was used in sign shops, in small machining shops. They were tools that existed fairly prevalently and just gradually came down in price. And the lasers that are becoming affordable and depending on your exact threshold, have been affordable for some time and are getting more affordable, are the direct descendants of that process. Part of that means that a lot of the discussions that happen around how to use laser cutters come out of either people who run shops talking to each other or woodworking forums, which have a strong culture of sharing tips and helping each other, but not as much of sharing finished products. There's also a lot less uniformity between machines, and so machines and materials, and so full ready-to-do projects are not as commonly found. There are plenty of free laser cutting plans on the internet, but there is no repository like Printables, MakerWorld, or Thingiverse. There are a few files on some of those platforms that are meant for laser cutting, but it can be a little bit more intimidating to get into because there's not as much of a hello world intro. Fortunately, most laser cutting plans are actually simpler to make yourself than designing for 3D printing, because it deals with 2D images instead of needing to learn full 3D CAD or modeling. And you can also even just use raw images if all you're looking to do is engrave. And there is no shortage of raw images on the internet. When you are looking at getting a laser, there are several considerations to make. The first is what you're going to be frequently cutting. A lot of the hobbyist lasers are either CO2 lasers in the 40 to 100 watt range, or diode lasers, often in the 5 to 40 watt range. Diode lasers and CO2 lasers both work readily on things like foam and paper. For materials like wood, you'll be able to cut faster the more power you have, but both of those again can approach those. Other materials can be more laser specific. If you're cutting acrylic, clear acrylic is clear in the spectrum that diode lasers use, and so diode lasers are unable to cut clear acrylic. CO2 lasers are a different frequency, and clear acrylic is opaque in that frequency, and so you're able to cleanly cut acrylic pieces. If you intend to work with metal, fiber laser will almost certainly be your best fit. Although there are higher power CO2 lasers that can cut metal, I don't believe any of those are in the hobbyist range, either in size or in price. That's getting into the those ones usually have 10 to 100 times the power of hobbyist CO2 lasers. As far as electricity use, most of these are actually lower than you would expect. If you were setting up a side business where you're running the laser most of the day, almost every day, it will cut. It could add up, but if you're mostly making things for yourself, I have found that I don't even notice on our electricity bill when I've got a heavy month versus a slow month, because even in a heavy month, I'm using the laser for at most a couple hours a day. And as I look at our instantaneous electricity usage, it makes less of a difference than our HVAC by a substantial measure. One of the big benefits of CO2 lasers is that they very often come with full enclosures, which makes them easier to use safely. Mine has an enclosure, and this is fairly uncommon, that has switches as well, so it can sense that it is closed, and if you open it while it's in process, it will immediately pause and turn off the laser itself. Diode lasers with an open gantry, diode lasers sometimes come in an enclosure, but often for cost-saving reasons come as just an open gantry, which simplifies the machine and decreases the cost, but also increases the risk and makes it absolutely essential that any time that this laser is on, that you are wearing eye protection, which is usually goggles, such as here are the goggles that I use for this particular laser. And also that you make sure that anyone who is in your space also has eye protection, and that pets are either excluded or we're in a maker community. If you want to figure out goggles for your cat, go for it. But but if you can have an enclosed space where you can be sure that no one's going to enter and accidentally get exposed to the laser, that is an important element for unenclosed lasers. You generally do, it depends whether you buy a laser that comes with a built-in enclosure or need to build your own enclosure, but anything that has an enclosure is going to be more expensive than the one that doesn't, because it is a substantial addition to the complexity of the machine and the resources. And sometimes the large plates of plexiglass tinted the right color to give you visibility so that you can see what's happening, but also to block out laser light, are not always cheap materials. The cheapest enclosures will often be opaque, because then you don't have to worry about whether that is matched up. But if you have but it can be very nice to have that window so you can see things as they're happening. One of the benefits of laser cutters is that they can be a lot faster to make pieces than a 3D printer because uh, depending on uh, it does depend largely on exactly what you're making, but uh, they can cut out things in a matter of seconds if what you're going for is a good match. Um, one of the examples of things, it also varies material by material, but one example of a material that I really enjoy using is EVA foam. It's very useful for costuming in general, and it also cuts with incredibly low power. And you can get nice, clean images. I'm about to share my screen with two images of things that I have made for out of EVA foam with my laser cutter. On the right, we have Valentines that we made to give away with our dragons. You can see that I've both cut out hearts and etched an image onto the heart. Both of these were using vector operations, which is part of why you see such a clear line. The only real difference as far as the machine operation goes is the amount of power. You do have to do some tuning to figure out which levels of power will cut through versus marking in a satisfactory manner. But once you have that, it's very quick to churn out. And each of these took under a minute to create. And I was able to make hundreds of them to give away to neighborhood kids who came to see the dragon on Valentine's Day. This is a more complex version where I cut out several things out of different colors of foam and puzzle pieced them together. But it works very well for making text that is nice and solid and has a uh, good look. We also took this approach when we made the sign saying "Oh no, not again" for the petunias with our whale and petunias costume. Okay. One of the ways to access a laser as well, without having to purchase your own and go through that process, is by looking into makerspaces and libraries. If you have a makerspace around you, it's fairly common to have a laser, and libraries are more and more libraries are getting them as well. One benefit to going this route is that they will often have something that is more a more expensive laser than makes sense for an individual to purchase. They're usually some of the higher quality CO2 lasers that you'll end up with either a larger working space or sometimes a more rigid laser that allows it to operate at higher speeds. They often also have higher powers than the consumer lasers. If you are lucky enough to have a makerspace or a library that has a laser cutter, there's also often people who are familiar with its use that are happy to help with some of the learning curves of how specifically to use it and how to prepare your items both physically and digitally for the cutting process. I am now going to shift a little bit more into talking about some of the specifics of how we have used lasers. My most frequent usage is in cutting out pattern pieces. When we sew our inflatables, we often make pieces that are very include pieces that are very large, and we've been creating these patterns mostly ourselves, whether it's scaled up from a plushie or created entirely from scratch. And one example is on our core oak that we made last summer. I believe Okay, I have an image here of scaled. You can see my wife's height, and this one has the main body of it is a very large piece. I assume many of you have had the experience of printing out a 100-page PDF and trying to line up all the registration marks in a mirror, or if you're lucky, a light table, before cutting it out to get the shape that you want. Shortly after I got the laser, I realized that I could do something similar, but that I would cut out a lot of steps. That if I, instead of having it automatically divided into PDFs, I could break it into pieces that I could laser cut and add registration marks to make it easy to align them. And because the laser cutter has the option to cut as well as print, each of these pieces is already cut out along the edge, and the registration marks can be much easier to line up because they are actually cut through the paper. Here is the example that I've been showing digitally. Once it's been assembled, you can see the stars line up exactly. That makes it very easy to align and make sure that it's put together. This cuts down assembling a large pattern piece from something that can take an uncomfortably large portion of a day to something that I can usually get done in under an hour. And depending on the size of paper or a laser cutter bed that you have available, you can increase the savings even further by breaking it into fewer, larger parts. One of the major benefits of laser cutting is the precision and repeatability. We haven't used any laser cut leather for costuming purposes, but I have done a bit of leather working. And one example is I made a wallet and was able to include the holes in the file itself. Part of that benefit is that as you cut it out, they align perfectly. And even as you stack them, you can see they line up and the holes match up exactly, which makes it a lot easier to sew together when you are getting to that point of the leather working process. They also match up incredibly well, and it can be very satisfying to simply stack a pile of things that you have laser cut and feel how they're all exactly the same height. I have also used laser cutting to create stencils and templates, basically creating tools to make it to simplify other cosplay elements outside of what we're directly working on. And since I have built that larger diode laser, we've even been able to directly cut some pieces, including all of the pieces that we made for our Katamari costume this past summer. And it does not look quite like this when you're watching, because if you're watching in person, you're watching it through glasses, and it will be a lot less blue to block out the specific light. But having a large format, low power laser cutter has been really nice to allow cutting out fabric directly and skipping the process of assembling paper patterns. I haven't been seeing all of these questions, but to answer one of Anne's questions about the registration marks, yes, these registration marks are actual holes, but they're holes just in the paper, so that you can use it to align the pieces of paper and then use the broader assembled paper as the pattern piece to cut out the fabric. And so the fabric itself doesn't have those holes. When I have cut out things directly, then I would not use the registration marks and just have the individual pieces. What were the other things? And also asked about iron-on transfer sheets. You can buy laser-safe iron-on transfer sheets that are not made out of vinyl. The problem is that the majority of things made for the Cricut or Silhouette vinyl cutter ecosystem do contain vinyl in them and are therefore not safe to cut with a laser, either for your health or for the machine itself. And so while you can do iron on, you have to source specific laser safe iron on materials. We have done that, but more frequently we have a Silhouette cutter that allows us to use the vinyl that we get from Michaels instead of planning ahead far enough in advance to order the laserable materials. I have frequently used stencils for lettering, and it is very nice. I have my overhead transparency paper is my favorite thing to use for stencils because it is clear, so it makes it very easy to align with the right part of whatever you're trying to paint. And with the laser cut elements, it's much faster than overlaying it on a printed piece and cutting out with a X-Acto knife or any other method that you might have of creating vinyl lettering. One of the most fun things about having a laser is trying out new projects on different materials. There's a lot of fun to be had with wood and things that you can cut out of that. You can also buy 2-layer acrylic, which is great for being able to make name tags. I have one at hand that I made for a friend that I haven't given yet. They end up looking very professional without an incredibly high amount of effort, because you simply engrave away the top layer and all that remains is the visible secondary color. This can also be useful in making costumes. If you have something that you need to be rigid and two-toned, especially if you do have a costume that includes a name tag of sorts. This is a great way to have a very official looking name tag. I have also found that having a laser has been nice for foam work, beyond just make the 2D images that I've showed before. I unfortunately don't have good images of those projects, but when you're cutting things to make out of foam, very similar to laser work, to leather work, you can cut out the entire pattern to begin with. It does have the downside that all of these cuts are going to be perfect vertical cuts, so you can't get the beveled cuts that you occasionally need to shape foam. But for pieces that are meant to be straight cuts, you can get very precise, repeatable cuts. And I've even seen people cutting feathers or scales for scale mail and cutting thousands of exact duplicates to be able to have the results be very uniform from piece to piece. I guess the limit for thickness depends on a few variables. One of them is the power of the laser and how difficult it is to burn a given material. When I'm cutting the lightweight fabrics that we use for our inflatables, I'm using a very weak laser on a fairly low power setting because it takes less power to cut that fabric than it does to even mark paper. as you scale up to different materials, foam also cuts very easily for its power, and you can generally cut pretty thick foam. Um, the limiting factor with foam is often going to be the focal length of your lens. Uh, Different lasers uh, have are focused down so that the cutting happens at a point where it's higher intensity than the general laser beam. This is especially true for CO2 lasers, where it has a broader beam that gets bounced through the gantry, and at the lens, it gets focused down. Um, most common are either 2 or 4 inch focal lengths that then tell you the center of the cone of light. Um, there's usually some space above and below that center point that is also useful for cutting. But the further away you get, the lower the intensity of the light is going to be, and the more difficulty it will have cutting through. So if you're cutting through something very thin, you can get it lined up perfectly so that the center of the cone is in line with the material. When you start cutting thicker materials, you need a longer focal length so that that center is spread out. But with my laser cutter, I can cut up to 1/4 inch wood um, fairly in a fairly straightforward manner. The more powerful laser cutters, like you might find in a library or makerspace, can often cut 1/2 inch to 1 inch of wood and acrylic. Um, I have personally used those abilities a lot less frequently, as I more frequently work with the thinner materials. Um, but when you're dealing with foam, you can cut through 1/2 inch to 1 inch with very low difficulty and still moderately high speed. When I'm cutting a 1/4 inch wood, it does it you do need to go much slower. This ties into the previous question of how many power settings the laser cutters have. When you're cutting with a laser, you have two main parameters that get changed: the speed that it's moving and the intensity of the laser. The intensity is usually set as a percentage between 0 and 100, which will vary from laser to laser. 100% on a 5-watt diode laser is a very different setting than 100% on a 100-watt CO2 laser. And so usually you will have to do materials testing on your specific machine before you cut your final project to dial in the settings and make sure that you are cutting through sufficiently, but not using an excessive amount of power that could cause charring or flame. One of these hexagons takes, if I remember correctly, about 3 to 5 minutes. If you're cutting simple shapes, that can be pretty quick, especially if you want a lot of them. The more complex of shape you want, though, the more time it takes because it's a longer path that it has to trace. When you are engraving, when you are raster engraving, it's a different calculus because it's only the total area that matters, because the laser has to scan each line all the way down, regardless of how much space there is filled in the image. And so that's a function of the total area rather than a function of the complexity of the lines in your artwork. If you're doing a vector-based engraving, then it's tracing each individual line. And so simple shapes get cut very quickly, and complex shapes can add time. Yes, these edges are black because they're burnt. This specific one has a lot of blowback on the back as well. This was the result of using too high of power, and so there was remaining power that bounced off of the base of the laser cutter enclosure and back up onto it, and the burnt smoke left this piece a bit charred. Though these are actually negative pieces from something that I was cutting out. They just happen to be good examples and useful to keep around. One of the common uses of laser engraving that I have less that I personally have less experience with is the raster engraving. If you've ever seen the wood burnt looking shops that exist at that I've seen a couple at basically every art fair and convention I've been to in the last several years. Those are often raster engraved, which gives a lot more flexibility in the images you can represent, and lets you wood burn an image from a machine directly onto the result. As far as costuming goes, I have seen that used to add texture to foam, doing things like adding scales all as one piece rather than having individual scales that need to be assembled. And I think that's about all that I had in my notes. And I'd like to spend some more time with questions if people have questions to ask. Yeah, laser cutters with leather can be very nice because it cuts so cleanly, and can it also cut the holes for the stitches that it simplifies the process of assembly. When you have a laser cut leather project that you're stitching together, the holes are always perfectly aligned. And you can also engrave to have textured leather as well. I guess to have a bit of a visual, back to the wallet pieces that I was sharing earlier, here is the wallet that I created with those pieces. This is, and because everything is perfectly aligned, you can make something that looks like it was made by someone who knows what they were doing, instead of my first leather project that I did after not counting scouting as a teenager, because it's all perfectly aligned and the pieces are identical height and exactly through the same height. Software is one area of complexity. There, I guess since I was on the wallet, jumping back to that, yes, this is a hand saddle stitch, which is for leather work. If you're going to do a saddle stitch, it's often nice to punch the holes ahead of time, which can be a big pain to do with a hole punch. But that is part of why the laser simplified that so much, because all of those hundreds of holes are done by a machine that doesn't get sick of doing it, and you can skip straight to the slightly less tedious bit of stitching it. On the front of software, many machines come with their own software, but more and more commonly, machines are
because lasers can cut thicker material.
More and more commonly, machines are using generic, or at least made to be compatible with a generic software. Lightburn is the most commonly used software. It is built from the ground up to be software for running a laser cutter. It is roughly $100, if I'm remembering correctly, for a license that gives you a year of updates and then perpetual access to the last update you had. many laser cutters come bundled with a key to download this. If they don't, they give Lightburn has a 30-day trial period that you can start out with to see if it meets your needs or not. It is I have largely been historically I'd been using the software that came with my machine, which was not very well suited because my machine got not very well developed because my machine got discontinued shortly after I purchased it, and so they continue to support it physically, but not by improving the software. Sending files from a machine to a laser cutter is often done either by having a flash drive that that you can write G code onto and then plug into a control module on the laser cutter itself, or sometimes it's driven directly from the computer with the this or a different software directly sending G code to the laser cutter. With a lot of the cheaper laser cutters often don't have the ability to cut on offline and have to be powered directly by an external computer. And this will meet those needs, allow you to do things like moving to align to select a portion of the space to cut, to use framing where the laser cutter will jog around the border of what it's going to cut, so you can make sure that it's cutting the right area. These also have materials libraries where you can keep track of settings that you have dialed in for different materials that you use. One thing to keep in mind is that, especially with diode lasers, the same material in different colors can sometimes work differently. I have a setting here for sil poly, which is the fabric we use most often, that is not blue, because with the blue diode laser, you have to have either a higher power or sometimes it won't even work. I've attempted to cut some white fabrics that didn't absorb the laser in this spectrum, and so I was unable to use the larger form factor laser I have. It had to restrain myself to only cutting out things that I could fit on my smaller CO2 laser that was in a more suitable wavelength. The laser cutter is often an output device, kind of like a printer. The drivers, I think, are usually bundled together with a software. Lightburn is, as I'm showing currently, is one of the more common ones. Laser Gerbil is a free one that's much less featured, but is still able to take vector graphics and send them to the send instructions to the machine. Philip asked if it's possible to use software like Photoshop to create and design and then convert to the required format. It's the most useful software for making laser designs is going to be something that's vector based, like Adobe Illustrator or Inkscape. If you are using raster engraving, then you can do any photo manipulation project, use any photo manipulation software like Photoshop or GIMP or Printmaster or Google search. But when you want to use the cutting features of a laser, you need to have something that is made of individual lines rather than pixels. This is largely going to be working with SVG files. And likewise, if you're looking for things to be able to cut out on a laser online, SVG is the key term I would search for, because the scalable vector graphics are what include the right information. The laser cutter knows the firmware that translates into laser instructions can take these paths that have that are instead of being composed of pixels at a given area, they're mathematical formula for calculating the path to draw this. The laser can then follow that same path, and instead of drawing pixels on a screen along that path, it can move the gantry or galvo to trace the point of the laser along that path to cut or engrave the underlying image. SVG design is a different way of thinking about things than the pixel-based images that are most common on the internet. It has pros and cons. One of the pros is that it can scale infinitely without having to worry about pixelization. One of the cons is that things like shading are much more difficult. But when you're cutting out, that's not usually a relevant element. The biggest con is that most people are not familiar with thinking about how to create things as a vector, and you need to think about whether there are hidden lines, because the difference between a line that's drawn once and a line that's drawn twice, while the rendered image might look identical, if you're cutting a path and you cut that path multiple times, that can be more difficult. Thanks for the reminder on that point, Kathleen. Yes, Kathy, I do send designs to be cut sometimes. One of the fabric suppliers that we have, Dutch Wear Gear, has a laser cutter, and you can send them files to cut the fabric that you order from them, and they will package up the pieces that they've cut and send it directly to you. 1 second as I open up an example of a file I've sent to them that I can share. One example that we had sent out to be cut was the whale that we made for this last costume con. Can everyone see that image that I'm sharing? When you send it, you want to make sure that you have deleted everything from the file except for the specific lines that are going to be cut, because they will cut every line that's included in the file. The initial image that I had, the initial pattern that we created, I had seam lines and a couple of markings for alignment. But then when I copied it over, you need to remove those extra lines, as well as make sure it's laid out in a pattern that will fit inside of their laser cutter. The size limit for laser cutter pieces varies depending on the size of the laser you have. The lasers that I have are a 12 by 20 inch CO2 laser, and that was my only laser for years. I recently built a 40 inch by 40 inch diode laser, and I've been planning to try and build a larger one so that we can do more rapid iteration on larger projects. The biggest issue, I actually have the parts for that. The biggest issue is that I'm held back by trying to find a place that it can live and be stored when it's not in use. The laser that Dutch Wear Gear has a bed that is 58 inches wide by 152 inches long. And so they can cut very large pieces. They do sometimes have shifts in the fabric as it's moving, and so you'll end up with a disjoint bit. If it messes up the final piece badly enough that it's not usable, we as happened with our first attempt on this whale, they were willing to recut it and send us a repair. And so it did work out in the end, but it slowed us down a bit on that. So be aware that if you're sending something out to be cut by somebody else, you are like you should keep in mind that any work that you're not doing directly yourself has the risk of being done not up to the standards that you want and not necessarily being up to your needs and needing to slow you down to be redone. For making scaled prototypes, we frequently use our laser cutter when making scaled prototypes. One of those examples is with when we did that core oak, because scalable vector graphics can be scaled infinitely. We were able to start off with pieces about a foot tall that were much less fabric, could be cut on the laser that at the time was the only laser I had, and allowed us to sew them quickly together and get a feel for the shape before scaling up to something large. That approach works especially nicely when you're trying to get an idea of broad shapes. As you scale things up enough bigger, sometimes the material thickness and the differences between how materials behave at different levels can start to show up. But as far as getting a general idea for how things look, the scaled prototypes are a very useful aspect of the laser. And let me stop the sharing for right now. See, are there any other questions? Yes, when you're looking for purchasing a laser cutter, there are currently many brands that are mostly selling machines made in China under various labels. Atom Stack and X Tool are two of the more common ones currently. OM Tech is another. All of these have a range of laser cutters, different types of machines at different price points. If I were replacing my current CO2 laser, I think the X Tool P2 is likely what I would go with. It's a slightly more powerful machine in roughly the same form factor. I think it's 12 by 24 instead of 12 by 20. I can't remember exactly off the top of my head. There are domestic manufacturers of lasers. Full spectrum laser is one of those. Epilog is another. Those machines tend to be on the more expensive end and also more focused at small business type uses. They are more robust machines with generally more robust support as well, but their prices can be harder to justify if you're not going to be also using them to make money in some way. Are there any other questions that I have missed? Let me scroll back through here a little bit. Yeah, for building my own laser cutter, there are a few different approaches you can take. What I got was a kit that I bought off of AliExpress. You can build similar things either buying a full kit from places. You can find them all over the internet. Open Build's part store, it is probably the most reputable place to get a kit or individual parts, especially if you want to have something that is very specifically bespoke. They have a large amount of extruded aluminum, stepper motors, belts, the hardware you need to assemble it, and they have laser heads, so you could build a diode laser in whatever form factor you wanted. They also have a few different base plans that you can use. The Open Builds Acro is what most large format diode lasers are based on. It is an open source design, so you can either follow it directly or make tweaks to it. And if you find a cheaper laser kit, it is often also based off of that. Um, it is cheaper to have something you've built yourself. Even when you buy the laser cutters, they usually come partially assembled if you're buying the lower end diode lasers, because it's hard to ship something that is a big square with an empty area in the middle. And so they'll ship the individual pieces, and you'll have to at least assemble the gantry. I have been building to try and make a customized laser cutter that is that meets our needs of having a very large area of very low power, because what we're cutting is not demanding from the laser perspective, but is demanding on the size and shape perspective. We tend to work with very large individual pattern pieces that are hard to get cut on any consumer machines. Alignment. Alignment is an important element. It depends on how, as many things, it depends. If you are just cutting out of a plain piece of material, alignment only matters enough that you get it aligned to ensure that the entire path of the laser is going to fall on the material itself. If part of the path of the laser is off the material, obviously it won't be there. At that level, it's largely like aligning a pattern onto fabric before you cut it out. It can be more critical when you are trying to do something that has multiple different laser jobs, where you want to make sure that they align with each other, or if you want to align with printed items. There are things. This is where you get into the benefits of the more expensive software like Lightburn. Lightburn has a print and cut feature where you can set registration marks inside of your image outside of the area that you're going to cut. And it will then walk you through aligning the laser with one of those registration marks and then the other registration mark. And then it can scale and rotate to exactly align the cut path based off of those registration marks. This can simplify that step and is a very large help when you're trying to align something that's been printed. And I've only used it once or twice, but it decreases the uncertainty dramatically compared to doing the same thing without that. How long did it take me to do the whale? So when we did the whale, a good amount of the time was in design. We started off with a purchased plushie pattern that was just a PDF for a whale about this big. I had to then trace that to get a vector that was the specific lines instead of pixels in the right place for the lines. We scaled it up to be as large as it is. I believe it ended up being 9 feet long. And then after it was at its full scale, we tweaked the seams to make sure that they aligned and that every matching seam was exactly the same length. That part of the digitization process is probably one of the slowest ones. Once we got to that point, we were able to send it off to get cut. And the only surprise we had was the issue where the fabric had shifted. And so there was a in the path of the laser a jag that was big enough that it made some of the pieces unusable. And we had to get them to recut it, but that same pattern actually worked and it came together beautifully. And as an added benefit, we had very large pieces left over with the whale that we were able to use for mock-ups for our next couple of costumes as I cut pieces out of those scraps that were left over. Generally, if you do have a surprise in your final cut, if you're lucky, it's a surprise that happens outside of the area that you need. If you're unlucky, it can cut into the necessary area and make you have to start over from scratch. But yeah. Maintenance on a laser cutter. Yes, the most important and routine maintenance on laser cutter is cleaning. You need to make sure that the lenses and mirrors stay clean. This is especially important when you're cutting sootier materials like wood. And one of the key reasons why it's so important is if you don't keep a laser cutter clean, you'll get a coating of dirt on the lens itself that can then cause the laser to burn the lens and ruin coatings. And at that point, you would have to replace the lens. Normally, the lenses last for thousands of hours of use, as long as you're sure to clean it, usually wiping it briefly every few hours of use, or more frequently if you're dealing with dirtier materials, less frequently if you're dealing with things like paper that cut very cleanly. A lot of laser cutters will have CO2 laser cutters are water cooled, and so you need to make sure that the chiller remains full. In the case of my laser, that just means having a jug of distilled water that I top it off from once or twice a year. In general, they're actually pretty low maintenance machines, though. Once they're working, the gantries are pretty simple and just keep working. Air assist can be a little bit of an issue, because you have to have a compressor and then a tube that takes the air along to the tip. That is one of those something that matters a lot with wood and less when you're dealing with synthetics, especially things like fabric. When you're cutting fabrics, the air assist can actually be more of a problem than a benefit, because fabrics are light enough that the air assist can move the fabric while it's cutting, and has occasionally caused issues where it will blow a cut piece in the path of the next thing that's getting cut. When I clean my laser, largely I'm just cleaning the main three mirrors and the lens. Every once in a while, I'll take it apart more thoroughly to clean out some of the ash that has accumulated. But for the most part, it takes care of itself. Okay, that's a great tip, that high percentage alcohol is the best thing to do to clean with. Interesting that it's got liquor tax issues. I have used isopropyl alcohol for cleaning in many cases, and it's worked pretty well for me. As far as materials that can't be safely used, vinyl is the big one. Other ones largely come down to having sufficient ventilation. It's not so much vinyl as chlorine. It's anything that contains chlorine is uniquely bad, because I believe it's hydrochloric acid that can get formed that will eat away at both the laser optics and your lungs. So if you look at the list of the MSDS and it mentions that it includes vinyl, it's something that's best to be avoided. One test that is not entirely conclusive, but a good rule of thumb is the burn test. If you take a small scrap of a material and light it on fire and the flame is colorful, that is often a sign that you should look into it a little bit more before trusting it to burn. If it burns as a normal, clean looking flame, then you're probably safe. Almost anything organic is going to be safe, although it might not have pleasant odors. It will, with sufficient ventilation, not cause challenges to your health.
Any other questions? Thanks so much for this talk. We really appreciate it, and I've learned a lot, and I've enjoyed your talk. So thank you very much.
Thanks, everyone. And feel free to reach out if you have questions. I do better in one-on-one problem solving situations than public speaking, but I wanted to put out the experience that I have. So I'm happy to answer more specific questions and will hopefully be even more helpful in those scenarios.
I wanted to talk about the next webinar that's coming up on December 8th, 2024. Cosplay Central Crown Championships is a major costuming competition with regional, national, and international rounds. Maral Agnarian, who is the 2024 national title winner, is going to be talking about the competition, her experience participating, and the costumes that she created. So that is on December 8th, 2024 from 1 to 2:30 p.m. Pacific time, 4 to 5:30 p.m. Eastern time. And there is a Facebook event for this, and we also send out announcements to the different costuming groups. So please look for that for the registration link. Announcements of upcoming webinars are emailed to Silicon Web ICG members. They're posted as events and notices on Facebook and published in Silicon Web's Virtual Customer magazine. Information on upcoming webinars also appear on the calendar page of the Silicon Web website, and here's the URL for that. Recordings of past webinars, including this one, are available on the webinars page. This webinar should be available within the next week, and I'll also include links to some of the sites that Taylor mentioned in the video as well. If you're interested in joining Silicon Web Customers Guild, information is available on the Join Us page at https://siwcustomers.org/join. So again, thank you all for joining us today, and we look forward to seeing you again at another webinar. And thanks again, Taylor, for making this presentation today.